All right, today we're going to go small. I mean, impossibly small. We are diving headfirst into nanotechnology, a field that works on the atomic level but promises to change, well, pretty much everything, from how we treat diseases to the very stuff we build our world with. So, you ready? Let's shrink down and take a look at this incredible frontier. Seriously, just stop and think about that for a second. What if we could actually build anything we wanted with perfect control, snapping individual atoms together like they were microscopic Legos? And look, this isn't just some sci-fi fantasy. This is the actual question driving a massive technological revolution. It's the whole promise of nanotechnology. So here's the game plan for today. First up, we've got to wrap our heads around just how tiny this nanoscale world is. Then we'll get into the really cool stuff. Amazing applications like nanobots that hunt down cancer and even concrete that can heal itself. We're also going to take a look at the surprising beauty that scientists are finding at this scale. And finally, we'll talk about the really big challenges that come with this tiny tech. Okay, so first things first, we really need to get a feel for how incredibly small nano is. Because when you get down to this level, the normal rules of physics kind of get weird, and materials start to behave in totally new and powerful ways. So what are we really talking about here? Well, the official definition says it's all about playing with matter on an atomic and molecular scale. The sweet spot, the magic window, is between 1 and 100 nanometers. It's in this tiny range where materials start doing all sorts of incredible new things. They can become way stronger, better at conducting electricity, or interact with light in ways we've never seen before. To really put that in perspective, think about this. A single strand of your hair, that's about 80,000 nanometers across. A regular sheet of paper is 100,000. So a nanometer is just mind-blowingly small. Yeah, we are literally talking about the scale of individual atoms and molecules. You know, this whole idea has actually been around for a while. It kind of started with the brilliant physicist Richard Feynman, who way back in 1959 gave this amazing talk basically saying, hey, there's a ton of room at the bottom. He was dreaming up a future where we could build tiny machines atom by atom. Then in the 80s, a guy named Erich Drexler really brought the idea to the mainstream. And now, today, it's not just theory anymore. This stuff is happening. It's moving out of the thought experiments and into our labs, our products, and even our bodies. Okay, so now that we get this scale, let's look at where this tiny tech is making a huge difference. And honestly, one of the most exciting places is medicine. I mean, we've all seen the movies, right? Tiny little robots zipping through your bloodstream, fighting off diseases. For decades, that was pure science fiction. Well, not anymore. Let's take cancer treatment. For a long time, chemotherapy has been, well, kind of like a sledgehammer. It floods your whole system with powerful drugs. And yeah, it kills cancer cells, but it also damages a lot of healthy cells, which is why the side effects can be so brutal. But nanobot therapy? That's more like a sniper. It's all about surgical precision. So, check this out. Here's how it actually works. You get an injection of these nanorobots, which are often built from things like folded-up DNA. They're programmed to swim through your bloodstream, hunting for the specific markers on cancer cells. Once they find their target, they lock on and release their medicine, zapping the disease right at the source and leaving the healthy stuff alone. It's a powerful, targeted strike. And that leads to this incredible idea, perfectly captured in this quote. The ultimate vision here isn't just about little delivery drones. We're talking about creating active, programmable nanosubmarines that can navigate our bodies, diagnose problems, and perform complex medical procedures all from the inside. But hey, it's not all about medicine. Nanotechnology is also completely changing the stuff we build our world with, making materials stronger, lighter, and get this, even smart enough to fix themselves. Just look around you. Our infrastructure, our bridges, roads, buildings, it's all getting old. It cracks, it wears down, and keeping it all maintained is a huge, expensive problem. But what if it could just heal itself? It sounds like magic, but here's the trick. Scientists are basically embedding the concrete with microscopic, dormant bacteria. Think of them as a tiny construction crew, just taking a nap. Then a crack forms. Water seeps in, and that water is like an alarm clock. It wakes up the bacteria. They start eating nutrients mixed into the concrete and produce limestone, which patches the hole from the inside out. Amazing, right? And it's not just about self-healing. Nanotech can also give existing materials superpowers. Take a look at this gray tech plastic. By mixing in just a tiny bit of this stuff called graphene, which is basically a sheet of carbon that's only 1 atom thick and is insanely strong, the plastic becomes 20% stronger and nearly 20% lighter. What does that mean for you? Well, it means things like car parts that are way stronger but also lighter, leading to safer and more fuel-efficient cars, all from a tiny pinch of nanotech. Okay, so we've talked about medicine, we've talked about materials, but believe it or not, the world of nano is also beautiful. It's a place where science and art just smash into each other in the most incredible way. See, when scientists use these incredibly powerful microscopes to zoom way, way in, they don't just see random blobs. They see these stunning, intricate patterns. Structures that look like they were designed, like tiny galaxies or abstract paintings. It's almost like we're finally getting a peek at nature's hidden blueprint, a layer of beauty that's been invisible to us this whole time. This discovery has actually created a whole new field, nanoart. And I love this quote because it really gets to the heart of it. A single beautiful image of something at the nanoscale can communicate the awe and wonder of this science to anyone. It grabs you. It makes you curious in a way a super dense, 1,000-page research paper just can't. All right, but let's be real. A technology this powerful, this revolutionary, it's not all smooth sailing. There are some really big challenges and some tough questions we have to think about as we build this nano future. So what are the roadblocks? Well, it really boils down to a few major questions. First up, safety. Are these tiny particles actually safe for our bodies and for the planet in the long run? Next, the technical side. Can we really manufacture and control these things with the insane precision that's required? Then there's the money. How do we make this stuff cheap enough so it's not just for the super rich? And maybe biggest of all, the ethics. What does this technology mean for us as a society? And this right here is a huge one. Because we're not just talking about fixing what's broken. We're talking about tools that could potentially enhance us, which brings up all these thorny questions from sci-fi classics like Brave New World. So where do we draw the line between therapy and enhancement? And who gets to make that call? So, when you boil it all down, nanotechnology gives us this incredible, almost godlike ability to manipulate the very fabric of our world. We're learning how to use the fundamental building blocks of the universe as our new construction set. So the question we're left with isn't just what can we build, but a much bigger one. What will we choose to create?